evaluate this double integral over the region D, where D is the region bounded by the curves y equals 0, that's the x-axis, y equals x square, parabola, and x equals 2. Here is a vertical line, x equals 2. So basically we are just looking at this region, and this region is type 1. The bottom curve is y equals 0 and top curve is y equals x square, so we can say this is type 1 region. Okay, then we can write this double integral as an iterated integral. This is same as first inside, so y goes from 0 to x square, so y from 0 to x square, so dy comes first, then dx, and our curve is just x cosine y. And for x, look at this curve, 0 all the way to 2, so x from 0 to 2. So we converted this double integral over the region D into an iterated integral. Now we integrate this function with respect to y and evaluate here, then do with respect to x. So this is same as x from 0 to 2. Inside we got a product and we are integrating with respect to x, with respect to y, sorry. X behaves like a constant, so cosine y, antiderivative of cosine y is negative sine y. Oh, just sine y, this is bad. Okay, this will be x sine y, because derivative of sine y is cosine y, and we want to evaluate this from y equals 0 to y equals x square. Okay, and we still have dx. So this integral for x 0 to 2, replace y by upper limit minus lower limit, so x times sine x square, x times sine x square minus lower limit y equals 0, so x times sine 0. Sine 0 is 0, so there is nothing. Now we need to integrate this with respect to x. Okay, so x times sine x square, we got a product of two functions in the x. Okay, so we need to do u substitution or integration by parts. Here x square x, derivative of x square is 2x. Oh, we have that, not 2x but only x, but we can always cook up that constant. So we need to make a u substitution, so let's do over here. Let u be x square, that means du equals 2x dx. Okay, we have two options, there is only x dx. We can always multiply by 2 and divide by 2, that makes 2x dx, that collectively du, and sine u. And at the same time, look, these limits 0 and 2 are for x, but we are converting this integral as a function of u, so the new limits should be in terms of u. So this is same as, let me write in this way, half outside. When x equals 0, go back here, u equals x squared, so u equals 0 squared, 0, so u equals 0, and upper limit 2, so u equals 2 squared 4, so this will be 4. Inside sine u, and now we are left with 2x dx, that is in fact du. Okay, let's do this integral. 1/2 antiderivative of sine u is negative cosine u, and u equals 0 through 4. This negative can be pulled all the way outside, negative 1/2. Upper limit cosine of 4, that's a decimal number, cosine 4. This minus is already out, so we don't have to worry about that, minus cosine of 0, which is 1. So this is it, negative 1/2 times cosine 4, which is a decimal number, minus 1. If you don't like negative, you can multiply inside negative 1/2 times negative 1. Let me write that first. 1/2, positive 1/2 minus 1/2 cosine 4. Do not simplify any further. Final.